when the conference team invited me to give this talk, they asked me for a presentation about where we've been and what's been accomplished. And I actually found that something of a challenge because while I don't actively dislike the past, I'm simply so focused on what's coming next that I'm more or less just comfortably indifferent to what's gone before. So I thought the easiest way for me to start then would be to give you some statistics. In the past quarter century, I've written about 3.8 million lines of open source Perl and Raku, and uploaded something to the CPAN about once every 3 weeks, in the form of 81 separate modules, most of which were actually serious. In the same time, I've given over 300 presentations, on average about one every month, for a total of just in excess of 1,000 hours of speaking. And I gave those presentations in 66 cities, in 22 countries, across 4 continents. That involved over 1,500 days of travel, about 4 years and 4 months away from home. And that 4 months was actually spent off the surface of the Earth in flight. The total distance I covered in that time was around about 1.4 million miles. Or, if you prefer, that's the equivalent of going 56 times around the Earth, or 3 times from the Earth to the Moon and back. So if you're wondering why I no longer travel, that's a large part of the reason. And all of that work, all of that development, all of that travel, all of that speaking was made possible by people just like you, the international Perl community. In the early days, it was through 2 large Perl Foundation grants. More recently, through 5 separate travel grants. Again, 2 from the Perl Foundation, 1 from the Frankfurt Perlmongers, and 2 from some very special private individuals who sponsored me to come and speak at particular conferences. In addition to that, I've had the support of over a dozen quite extraordinary people who have consistently found me paid speaking and training opportunities that have given me the free time to do all of that other stuff. Some of them over periods in excess of 5 or even 10 years. And of course, the grants that I received were the result of the donations from hundreds of very generous people. And there were literally thousands of people who simply showed up to the presentations that I was giving. And to every one of you, I am more grateful for the opportunities, for the adventure than I can possibly say. Now, interestingly, that 4 months that I spent on aircraft had an interesting side effect, because it turns out when you do a large amount of traveling, you're also doing a very small amount of time traveling because of Lorentz contraction. The formula looks like this, and it boils down to the faster you're traveling, the slower time passes for you. And that's why when you come back from the stars, your young daughter is now a senior citizen. So if we look at the physics of this, if I'm traveling around the world, either west or east, then I'm moving at a different velocity from if I'd stayed at home, relative to the stationary center of the Earth. If I'm traveling west, then I'm actually traveling slower than I would have been at home. If I'm traveling east, then I'm traveling significantly faster. And there's another effect going on here as well. Because I'm in an aircraft and not on the surface of the Earth, the gravitational force I'm experiencing is again very slightly different. And time varies according to the gravitational force that you're experiencing, according to this equation, which basically just means the higher you are, the faster time will travel for you. And that's why if you go down onto the hypergravity planet, when you come back, the young guy you left behind is now also a senior citizen. So those 2 effects on the passage of time either add up or subtract from one another, depending on which direction you're traveling. And in 1972, a couple of physicists actually tested this by taking 2 atomic clocks on aircraft traveling around the world in each direction and measuring the difference from an atomic clock that they left behind. And what they found was that when you're traveling to the west, you actually age about 275 nanoseconds faster than if you stayed at home. And if you're traveling to the east, then the 2 effects cancel each other out to a certain extent, and you age 40 nanoseconds slower. So on average, when you're traveling around the world in either direction or half the time in each direction, then you're aging about 120 nanoseconds faster than if you stayed at home. Which means for someone like me, who's in the past 25 years traveled around the Earth 56 times, I now live just under 7 microseconds in the future, which gives me a kind of useless superpower called micro-precognition. So for most people, the world looks like this. For those of us with micro-precognition, we live a tiny fraction of a second into the future, and the world then becomes a little bit blurred. It's not terribly useful. It's pretty much like the guy who is bulletproof, but only to every 13th bullet. Or the goddess whose arms detach, but she has no control over them when they're detached. Or the man with absolute immunity, except in New York when it's stormy. So having that ability to see just under 7 microseconds in the future is nevertheless the ability of seeing possible futures. And the interesting thing about that is seeing possible futures is kind of the same as being able to see alternative pasts. And that's what I'd like to talk about today. So obviously, those 4 images were created by AI. And at the moment, we're all thinking, is AI going to be the future? But for me, that's not the interesting question. For me, the interesting question is, what if AI had been the alternative past? What if I could take current large language model technology, jump in my DeLorean, and go back in time? Specifically, I'd like to go back to September 1999. For those of you who don't remember that time, everyone pretty much looked like this, except the people who looked like this. But in September 1999, I released a module on CPAN called Koi. And the idea of the Koi module was that it would rewrite your error messages. It would change the behavior of croak and carp and die and warn, so that when you gave them an error message, it would take that message and it would compose a haiku for you to try and soften the blow of receiving this bad news. You get a soothing haiku to start you off. Back in the day, that was pretty spectacular, but now, of course, it's so last millennium. If I wanted a haiku to ease the burden of receiving an error message, I would just fire up something like Claude and specifically ask it, here's an error message, could you please compose a soothing haiku that's relevant to this error message? And it would produce something gorgeous. And regardless of the error message you gave it, you get something relevant, something that scanned properly, something that was poetic. So let's jump forward a little bit, back in the DeLorean and up to May 2000, when I released a module called Text Auto Format. And the idea of this module was you would give it some text, presumably that you'd taken out of an email, and ask it to reformat that to a particular width. And it would do that respecting all of the conventions of email quoting and other things like being able to recognize any kind of bulleted point and preserve the bullets. Or if you have numbered bullets, then renumber it to make it sensible. So, of course, I had to find out whether a large language model could do this. So I fired up Llama 3, gave it that request, and sure enough, it had no trouble whatsoever doing the same thing for me. And it understood the bullet points, and it was even able to renumber them when I asked it to. If we jump further ahead to July 2014, I released a module called Lingua N Inflection. And the idea of this module was it gave you an inflect subroutine, which you could pass a string in which you had annotated important numbers and nouns and verbs, and inflect would then inflect the noun and the verb to match the number that you had also noted. So you would get grammatically correct output where the verbs and the nouns match the number. Now, of course, it's not going to be any surprise that a large language model can do that. So here, for example, is Google's Gemini model taking the same input and producing the correctly inflected output. The last time I gave a keynote was, in fact, June 2020. And in that keynote, I announced a module called Code Art. And the idea of Code Art was you hook this module into your editor, and then wherever your cursor is in your Perl code, it highlights all of the uses of the variable that the cursor is sitting over. And as you move through the code onto different variables, you get different parts of the code highlighted, indicating where those variables are being used, and it knows to ignore other variables of the same name in different scopes. So I thought to myself, there's no way that a large language model is going to be able to replace this module. But I tried. I gave ChatGTP a short tutorial on how lexical scoping of variables works in Perl. I gave it that code, and sure enough, it gave me back an annotated version of that code in which it had correctly identified the scope and relationship of every single variable in that code. So it turns out that the last 25 years of advanced programming that I've been trying to do can now effectively be completely replaced by glorified autocomplete. I wasn't, in fact, the mad scientist of Perl. I was merely the large language model of Perl version 1.0. So you might wonder why I'm not more upset about that. Why am I so calm about it? Well, CodeArt did more than just recognize the scope of variables. If you put your cursor over a variable, you could ask CodeArt to change it and all of the instances where it's used without messing with any others. And that's a bit better than regular substitution. So I thought, well, I wonder if ChatGTP can do that as well. I asked it to do so. It took that variable that I mentioned and was able to replace it about 60% of the time. In other words, it missed a couple of instances, which is the same as to say as it was putting a bug in the code by changing what variable that actually refers to. So I tried again with a variable of wider scope, and once again, it was only able to change about 2/3 of the actual instances. And in this case, it did even worse, because not only did it fail to change that variable, but for some reason it converted it from an array to a scalar. It should have been the array values instead. So from this, I concluded that ChatGTP, at least, is able to pass the Hunt-Thomas version of the Turing test. You might remember that Andy Hunt and Dave Thomas were the two guys that coined the term N-bugging for the process of unconsciously putting bugs into your code, which we all do all the time. So it turns out that large language models can embug code now at near human levels of performance. I'm not sure whether that's a good thing, but that's what they seem to do. So I went back a little bit and I thought, well, with my lingua and inflect module, I didn't just sit there translating nouns and verbs into the correct inflection. I actually wrote code that did that. I wonder what happens if you ask an AI to write code to do that. So I asked ChatGTP, and it produced quite a bit of Perl code, all of which compiled. It even had a little test suite associated with it. And when I ran that, sure enough, it was able to translate, again, only about 2/3 of these sentences into grammatically correct English. It missed these last two examples. Cities became ties, ladies became dies. So then I spent about half an hour trying to work out what was wrong with this, trying to coax ChatGTP into debugging it for me. And ChatGTP was just not able to do that. It couldn't find what the problem was, and it couldn't fix the problem. In the end, I had to go into the code myself and recognize that what was going on was that it was matching consonant followed by Y and replacing it with consonant followed by IES, which is a valid rule for English inflection, but all it was doing was matching the consonant and only returning that consonant with the IES. What it needed to be doing was something more like this, where it would capture the whole preceding prefix of the word and return that as well. And when I changed that, then the whole test suite ran correctly. But I had to change it. ChatGTP, I just could not convince to debug and fix that. That means that ChatGTP also passes the Kernighan version of the Turing test. You recall that Kernighan said that debugging is at least twice as hard as writing code in the first place. So if you write code to the best of your ability as cleverly as you can, then by definition, you're not smart enough to debug it. And so far, AI is debugging at that kind of near human level of performance, not smart enough to debug its own code. So that's why I'm not excessively worried about the rise of AI. My next job probably won't be writing code to solve someone's problem. But I don't think it's going to be telling an AI to write code to solve the problem either. I think it's going to be telling an AI to solve the problem directly without writing that buggy code that it can't fix. So at this point, if you've seen one of my keynotes before, you're probably expecting that I'm going to announce a whole series of modules that have this kind of AI augmented behavior in them and say they're all now on CPAN. But it turns out that's not necessary, because on CPAN already, there are a number of excellent modules that will hook you into any of the large language models that are currently available. And with those, you can create your own auto-inflection subroutine, which takes some text and hooks into, in this case, ChatGTP, builds an object with which you can interface with the ChatGTP API. You then just build an English language request, or any language you like for that matter, interpolate in the specifics of this call to auto-inflect, fire off that prompt, and whatever you get back, that is your answer. And indeed, at that point, you can auto-inflect a whole series of grammatically incorrect statements and get them back grammatically corrected. And you could do exactly the same thing for auto-format. Once again, you build an interface to the remote service, you build a prompt for that request, you interpolate whatever information is needed to specialize that prompt for this particular call, you fire it off, get it back, and now you have AI-based auto-formatting. We can even do it for the ancient Koi module. Set up the infrastructure to communicate with the language model, build a prompt that asks for what you want, interpolate the components that are specific to this error message, send off the prompt, get back the response, format it into a nice, elegant format, and now we have haiku that are far better, far more relevant, far more elegant than anything the Koi module could ever produce. Now, of course, all of those examples are following exactly the same structural format. All of them simply set up the interface, build the request, interpolate specific details that need to be part of that request, fire off the prompt, get back the result. So whenever I see something like this, where I'm doing the same thing over and over and over again, then I immediately jump in the DeLorean, go back to 2015, when I released keyword declare. And I can use the keyword declare module to take those infrastructure components that are not interesting in themselves and hide them away in a keyword. So I created a keyword, do what I mean, which takes a curly bracketed block of text and then simply replaces that curly bracketed block of text with all of that infrastructure for calling out to the large language model, interpolating the actual block of text as a double quoted string into the prompt. And now, if I want to auto-inflect, that's just do what I mean and ask it for what you want. And if I want to auto-format, it's just do what I mean. And if I want Koi to be implemented, I just do what I mean within the scope of calling carp. And in all of those cases, the keyword is simply replaced with the infrastructure, and it does what I mean. The only problem here, of course, is because it's a keyword, and because keywords can only appear at the start of a statement, in this case where I wanted to interpolate it into another call to carp, I have to put it in some kind of do block to make it the statement inside the do block. And that's kind of annoying. It'd be much better if it didn't have to be like that, if I could just implement Koi in 3 lines of code. But you can't do that with keyword declarations. To do that, you've got to get back in the time machine, go all the way back to 2001 when I released the filter simple module. And with filter simple, you can set up a source code filter. Whenever your code loads this module, the source following that load is going to be passed to this filter in $_, and then you can just do a big substitution on it. So you can look for any instance of dwim with curly brackets, not just at the start of a statement, but anywhere you like, and you can replace those, extracting out the curly brackets, turning them into a double quoted string, and then just calling the infrastructure in some little subroutine. And that works. Too well. The problem here is that that substitution is completely undiscriminating. It will find dwim and curly brackets anywhere in your code and replace it anywhere in your code. Not only in the places where you want it to do that, but in literal strings, in comments, in any other part of the code where you don't want that to happen. And that's why people don't like source filters, why they're kind of looked upon with horror and with dread. Because yes, they are an incredibly powerful tool for extending the Perl language, but what they really are is an incredibly powerful tool for putting in very subtle and hard to find bugs into the Perl language. But fortunately, time moves on. If we zoom back up to 2017, I released a module that solves that problem. And that module was the PPR module. PPR is a module that provides you with a regex that matches correctly any valid piece of Perl. So I could replace this simple but dangerous substitution filter with a very much safer one. I would use the extension version of the regular expression, and I would say, I want to match an entire Perl document. When you run this filter, I want to match an entire Perl document, except that I want to extend the existing rules for control blocks and for subroutine calls. And I want to extend them by adding the new dwim syntax, but correctly parsed as proper Perl. And I want to, every time I match one of those new dwim blocks, I want to capture the relevant information within some kind of lexical variable that's currently in scope. And then my actual substitution just works like this. I match that entire Perl with dwim block syntax. Assuming it matches, then it may have captured one or more of these dwim blocks. So I just iterate through each of those. I extract out the requests, convert them into the dwim code that I need, and substitute that back in to the original source code. And so now I can have dwim anywhere that I could have either a control block or a subroutine call and nowhere else. And this then just works and makes heart-rendingly beautiful error messages for you. The module is called dwimblock, and yep, it's now on CPAN. But I have to say, if you are seriously considering deploying code that applies an arbitrary source code filter and then pipes half of your source out to a large language model, then I think you really have to go home and rethink your life. But of course, as usual, the real treasure was not that, but it was the modules that we made along the way. Because what I just showed you was a source code filter that understands Perl syntax. I think that's actually worthy of exclamation marks rather than question marks. It'd be even cooler if you didn't have to write all of this horrible code to make it work. But of course, as soon as I looked at that, I realized the only bits of the code that were specific to solving the problem were these little bits of code. So once again, that's a perfect opportunity to create a module to simplify that syntax. So I created a module that gives you a new filter declarator. And the filter declarator says, I want to filter only this syntactic component of Perl, only control blocks or only subroutine calls. And I want to extend the existing syntax with this new dwim syntax, but using the internal PPR code to make sure that I parse it correctly. And whenever I find this new syntax, I want to replace it with this standard syntax. In other words, I want to return a string that's going to be interpolated by the filter. And that string is simply going to take the request. And where does it get that? It gets that from the named captures of the new syntax. And it all just works. It gives you a way of creating source code filters that understand and respect the existing Perl syntax and which you can now extend that Perl syntax safely. How does it actually do that? The module itself is one of those syntactic filters, but it's a meta filter. In other words, it's a filter that I wrote that takes your module code with filter declarations in it and filters those back to other syntactic filters, which you can then use to safely filter your source code. The module, obviously enough, therefore, is called filter syntactic. It's also now on CPAN. But if you're seriously considering deploying code that applies syntactic filters to your source, you know what? That's probably okay. Force Ghost Obi-Wan says, go for it. So far I've talked about the idea of applying effectively future technologies to upgrade some of the modules that I created in Perl's past. But I'd also like to look at the flip side of that, applying past technologies to upgrade some of Perl's future. And to do that, we have to go back to the earlier times, back only a few years to May 2020, when I received an email from the most dangerous Perl programmer on the planet, Ovid. At the time, he and I were working on the Corinna project, and that project was the one that produced the use feature class syntax that is now being added into Perl slowly. And what you get effectively is keyword definable classes with fields and methods, and attributes which can generate accesses for you automatically. And the methods can refer directly to the field variables as if they were closures over them, so you don't have to go through $self anymore. And it's all built straight into the language. So you don't have to use a framework, you just use Perl to do it. And back in May 2020, when I received this email from Ovid, he was asking about a particular situation that he'd come across in trying to use this new feature. And specifically, he said, I've got a tree class. And that tree class, I want the accesses for the children, for the left and right child nodes, to be the usual kind of Perl accesses. So if you pass an argument in, then it will set the left child of this node to that value. And if you don't pass an argument in, it will just return the current value of the left child. His point was that that was what these attributes were supposed to do. If you declared a field to be reader and writer, then you get a method of the same name, left in this case, which just does that behavior. In other words, that's just a shortcut for writing a method like this, where if you pass no argument, then you just get the value of the field back. And if you pass an argument, then that gets put in the field. But Ovid's point was that this standard kind of structure for an accessor doesn't actually work correctly in this case for a tree. And the reason is, of course, you can't just put some string that someone's passed in as the argument to left into the tree as its left child. It needs to be another tree node. So you have to wrap that up specifically in another tree object. So you can't actually use the automatic reader and writer because it's not going to give you the right behavior. You have to write your own method. And that's okay. That's expected. The problem is, of course, that it's ugly. And we're using $_0, which we should never really use. We should at least unpack @_ into a named variable for maintenance purposes. But here again, we're still using @_, which again is so last millennium. And Ovid's question was, well, what I really want to be able to do is use the modern signature syntax for subroutines and methods to remove that instead. And he suggested, well, I think I know how to do it. I could do it like this, where I provide left with a single parameter, but that parameter is optional. And if the argument's not passed in, then I simply set it to undef. The default value of the parameter is undef. And then I can just test for the undefinedness of that new value. And if it's undefined, I just return the current value because no argument was passed. And otherwise, I execute the assignment instead. But the problem that he'd recognized with this was that it works in the majority of cases. If you pass an argument in, sure enough, the default value doesn't get assigned. The value is defined, so it does the assignment. If you don't pass an argument in, the undef does get assigned to the parameter, and you just get the value back without any assignment. The problem was, what if you actually want to pass in as your value the value undef? And that's not unreasonable to want to do, but it doesn't work. That silently doesn't do any assignment at all because it trips the not defined of new value, even though the new value was actually passed in. It's still undefined. So the question was, is there some other way that I can set up this signature and this test so that that doesn't happen? So there are no special values that get passed in that then do the wrong thing. And I said, yeah, there is, but you're not going to like it. You can do this. You can declare a lexical variable inside the signature and then take a reference to that variable as the default value when no argument is passed in. And that lexical variable is lexically scoped to the block of the method. And so the only place that you can actually access that variable and therefore get a reference to it is inside that block. So now, if no argument is passed in, the new value gets assigned a unique value that simply cannot be found anywhere else. So it's absolutely safe. And of course, Ovid's immediate reaction was, is there any other way of doing that? Because that's pretty damn clunky. And I said, yeah, there is, but you're probably not going to like it any more than that. You can do this. You can simply say that when no argument is passed in, the default value is the result of return left. And of course, the return has a side effect of immediately returning from the method that it's inside, which is the left method. So at that point, when no argument's passed in, we immediately short circuit, immediately return left, and we're done. And then the body will only execute if there was an argument passed, and it can just take whatever argument that is and put it into the tree. And that is the most concise possible solution to this in standard Perl. Now, if you're thinking to yourself, wow, that is extremely clever, then you, my friend, are part of the problem. Because that's another way of saying that's essentially undebuggable. Kernighan has taught us that. So I said to Ovid, look, the real solution here has been around for a long, long time. In Perl, it's been available for a quarter of a century. And that solution is to use multiple dispatch. In 1999, I released the module class multi-methods. And since then, there have been any number of other modules put on CPAN that give frameworks for doing multiple dispatch. All the way up to Christmas 2015, when the Raku language was released, because it too has full multiple dispatch. What is multiple dispatch? It's simply the ability to declare two or more versions of the same named method which have different signatures. And then you select based on the number of arguments that are actually passed. So rather than writing this highly clever thing, you simply write two versions of the left method, one of which takes no arguments and just returns the value, one of which takes one argument and does the appropriate assignment. Now, the interesting thing is you can actually write this in Perl today. But if you do, it's not going to do what you hoped, because as soon as you declare the second version of left, that overwrites the first version with an error message, and you only get the second version, which is not what you want. What we want is to be able to have both versions operating and to be selected at runtime according to the number of arguments that were actually passed. And that's something that's incredibly easy to do in Raku with almost the same code, because Raku has this multi-modifier that you can put on a method to just say, look, there really are meant to be two of these with different signatures, and you're supposed to work out which one to call depending on the number of arguments that were placed. Now, in any of the frameworks, including my own DOS object-oriented framework, you can do the same sort of thing. They have this ability to specify this is not a regular method, this is a multi-method. There are multiple versions of this same method, and you have to work out what to do. And even back in 1999, you could have done that with the class multi-methods module, except that the syntax would have been considerably clunkier. So that's what I wanted. I wanted to make that work with Perl's new built-in classes. So that's exactly what I did. I created a module that when you load it, it gives you a new declarator. It gives you a multi-method declarator which says these are both valid for different cases. And now the case where you pass no argument calls the first version, and the case where you pass one argument calls the second version, even if that one argument is undef. And that was going to be it. That was going to be all that it was going to be. Just the ability to have two or more methods with the same name but different numbers of parameters selected by the number of arguments that were passed. But of course, I reckoned without the temptations of the dark side. So obviously that wasn't going to be all. And the reason it wasn't going to be all became almost immediately apparent when I went back to look at that example. Because there's actually a bug in this example, even with the multi-methods in place. And that bug appears because I'm not always going to be passing in strings as the value of my left child. What if I pass in an actual tree object already? Or what if I sometimes pass in a tree object and sometimes I don't, and sometimes I'm not sure till runtime whether I am or I'm not? Well, then I have a problem, because the body of the left assignment version always wraps up whatever you pass in a tree node. So if you're passing a tree node, you now get the tree node wrapped in another tree node before it's put in the tree. And that's inherently incorrect. So immediately I saw this second version of the multi-method has to get more complicated. I have to have a test initially that says, is this new value already a tree object? If it is, then I just assign it directly without wrapping it up. And otherwise, I wrap it up and then assign it. And of course, as soon as I have two or more possibilities within that one multi-method, then what I really have is two multi-methods. One multi-method where I pass one argument where that argument has the additional constraint of being a tree object, and another version where I pass the argument and it doesn't have that constraint. And that's perfectly possible to write with this new module. So in addition to doing number-based multiple dispatch, it also does type-based multiple dispatch. So having any kind of type-sensitive multiple dispatch solves another common, well, not even an OO problem, just a general problem of coding. And that general problem is the number of times we have to write code like this, where I have this long cascade of if, else if, else if, where I'm testing a condition and then making some response on the basis of which condition actually applies. And it might not be written like that. It might be written as just one big ternary operator, but it's the same fundamental idea. And anytime you see this structure, that is an opportunity for multiple dispatch. So here's an example that's a little bit more practical. I guess like most of us, I've written my own data dumper module any number of times. And so here is an implementation of a DD subroutine that takes some kind of data and data dumps it. And it does that by just working out what kind of data it's looking at and then producing the appropriate string-based representation of that data. And then you can pass in different bits of data and you get back the appropriate printout. So anytime you have that cascaded ternary or the cascaded if, else if, that's an opportunity for multiple dispatch. So I could have written that same thing in this way instead, where I have 5 different variants of DD, each of which have some kind of constraint on them saying you only use this variant when this constraint is true, except for the last one, which has no constraint upon it. So the first constraint here is not even a constraint on the parameter, it's a constraint on the call. It says if you call DD where want_array is not defined, that means you're in void context. And in void context, what we want to do is print out whatever's being data dumped. So we do that by saying whatever's being data dumped and recursively calling DD. Or you can say, I want to do these variants when this particular constraint applies, when the data is an array reference or a hash reference, or it matches this regex that I've developed for numbers. So it's a number. And then you've got the last case where anything else, we basically just print out as if it were a string. Now, these two cases where I'm looking at the type effectively of the argument being passed in, is that an array is at a hash reference, that's a little bit clunky. The attribute-based where syntax is kind of a little bit verbose. You're probably expecting something a little bit more concise and easier to read. And of course, the module, while allowing you to do this, also gives you a more concise syntax. You can just write this. If the data is an array, do this. If the data is a hash reference, do that. Now, of course, it's still saying that you're passing in a reference because it's going into a scalar parameter, so you still have to explicitly dereference it yourself. And that's also a little bit annoying, especially since Perl now has a better way of doing that. And nowadays in Perl, you can write this instead, not in a subroutine, but in other places. You can say, if I'm going to assign to a reference to an array, that is going to alias that named array to this anonymous array reference. And you can even do that in for loops. You can't yet do it in subroutines, but I've got a suspicion that eventually you'll be able to. In the meantime, if you're using my module, you can do it in multi-subs. So you can say, I still expect to receive a reference to an array, but I want you to alias that array reference to @data. And now, of course, accessing @data becomes a little bit cleaner. And the same thing down here with a hash, you can simply say, I want to pass in a reference to this hash, which I'm locally going to alias to %data. And now all of that syntax gets cleaner as well. Now down here where I'm doing where it matches this regex for a number, I thought, well, the module ought to let you do that too. You can also just say, I want to match this by using an infix operator. You can say, I want this variable to match this number. And you could do that with the base case as well. You could say, well, what I'm really wanting to do here is match something that isn't an empty string. Because if it's an empty string, I'd like to just put out a special optimized version of that for the empty string. But back here, numbers are still hard to get right in regexes, so you might prefer to use Toby Inkster approach. And Toby's approach would just be to say, I'm going to put a type-tiny type object, the number type object, as the constraint on this parameter. And that just works. Going back to the very first example where we were detecting that there was a void context call going on, Well, that works, but it's hardly obvious that that's what we're detecting. So the module also gives you an abbreviated way of writing that, where you can just say where we're in void context. And of course, you can also say where we're in list context or where we're in scalar context. Now, when we're in void context, of course, we have to recursively call this multi-sub again to actually get the thing that we're going to print out. And that's kind of annoying because it introduces a whole second level of calling. So I thought it'd be much nicer if we could just do what we can do with methods in Perl, which is in Perl with methods, you can say, I just want the next method in this hierarchy to take care of this for me. And here you can do the same sort of thing and say, I want the next available variant to handle this for me. Now, if you're going to do that, then it's not going to recall the same DD. It's just going to go back to the dispatcher and keep finding the next available DD that matches the argument. The only thing there, of course, is you want to make sure that this is the first one that gets called. So the module also provides a little mechanism by which you can say, I want you to try this one before you try all the others. So that's it. Data dumper in 6 lines of multiply dispatched, very readable code. The module has other very handy features. One of those is a feature that I stole from Raku, but that's okay because originally I stole it for Raku from Haskell. And that feature is called a signature literal. The idea here is that when you're writing these kinds of multiply dispatched subroutines or methods, what you find is very often you write something in this form, where you're trying to match against a particular pattern or a particular value, like empty string or undef, and do something special in that case. A more common example of that would be the Fibonacci function. In general, you just compute Fibonacci n-1 plus n-2, but there's the special case where n is 1 and the special case when n is 0, in which case they both return 1. Or you might want to have some kind of function that outputs fatal error messages. And if it's a general message, then you print fatal error and the message. But if the message is empty, then you don't want to have that kind of colon and nothing. So you just have a special case for dealing with empty fatal error messages, and probably another one for dealing with undefined fatal error messages, which are just weird. And the thing that I noticed about all of these special case variants is that in very many cases, when you look at the body of the code that's going to be executed in that case, the body of the code doesn't actually use the variable at all. And that makes sense because the constraint that we're placing on that variable tells us exactly what the value is going to be. So we kind of don't need to examine that value directly. So in many languages that have multiple dispatch, there's a shortcut for that particular case. If you're trying to match a particular value and you don't care about the parameter value itself, apart from it being that special value, you can just write this. The fatal behavior for an empty string is this. The fatal behavior for an undef is this. And you put the literal value that you're expecting to be there as the signature. And of course, that works equally well for the Fibonacci function. You can just say Fibonacci of 0 is 1, Fibonacci of 1 is 1, and Fibonacci of n is the usual. You can even do it up here because none of these use their parameter directly either. So again, you can just get rid of that binary constraint and say, when it matches this regex, when it is this empty string, when it is undef, do these things. The last feature that I'd like to tell you about, which is also stolen indirectly from Haskell, is a much more powerful one called destructuring. So here's a slightly larger example of the merge sort algorithm. And if you're not familiar with the merge sort algorithm, it kind of works like this. When you want to sort a list, if that list has less than 2 elements in it, then it is inherently already sorted, so you just return it. And otherwise, you break the list into 2 approximately equal halves. You recursively sort those 2 halves, and then you merge the 2 sorted sublists together by taking the smallest element from each of the lists at any one time and making a single sorted list. And that merge behavior is itself relatively simple. If one of the 2 lists you're trying to merge is empty, then you just return the other one because it's kind of the merge of the 2 then. And if both of them are not empty, then you compare the first element in each of the lists and you return the smaller of those 2 first elements. And then you recursively merge the remainder of that list with the other list. And that's a well-known, pure functional algorithm, the merge sort. Now, the obvious thing here is the merge sort itself has a cascaded ternary, so it could be written as a multi-sub. The merge sort of nothing is nothing. The merge sort of a single element is that single element. And then the merge sort of any other list is just the recursive split sort merge. And of course, we could also apply multiple dispatch to the merge part of the algorithm as well. The first thing that we could do is we could make these more useful. Rather than just saying we're passing in 2 array references and let's just hope that we actually get array references, we could put constraints on there and say they have to be array references, and when you get the array references, alias them to these 2 local arrays. And when you do that, then all of that syntax gets a whole lot simpler. Now, of course, again, we have a cascaded ternary with a couple of preliminary simple cases, so we could factor those out into multiple variants of merge. We could say, if you get an array reference where the array itself is empty, then you just return the other one. But again, that's kind of a little bit ugly, a little bit verbose, a bit hard to read. So in most languages that have this kind of multiple dispatch feature, there's another way of writing it. And that makes sense because in Perl, there's another way of writing a reference to an array that has no elements, which is much cleaner and much easier to follow. And we simply write it like that, where I literally say, what I'm expecting here is an array with literally nothing inside it. And of course, I could do the same thing in this case, where the Y array is supposed to be empty, and I could write it like that. And that's just a special case of a more general feature, which is that using this destructuring mechanism, you can describe the internal structure of a container that you're passing by reference. So we could do the same down here. We could say, well, I expect that the X array must consist of at least one scalar element and then possibly some more elements that I would slurp up into an array parameter. And these are like sub-parameters. That's still only one parameter, but when you find that array reference, deconstruct it into the initial scalar and the greedy extras, if there are any. And you do the same thing with the Y. And now this syntax gets a whole lot easier, and this syntax gets a whole lot easier, and you can't win everywhere. This syntax gets a little bit more complicated because we've done away with those actual arrays. They're now deconstructing when the signature matches. So we have to reconstruct the arrays that we don't pull an element off. But overall, it's still syntactically a win. And of course, now we notice, hey, that's a ternary operator, testing some condition. So I could convert that one variant into 2 variants. And I could say something like this. When you unpack the first element of the second array reference, compare it against the first element of the first array reference, which you've already unpacked. And if it's in fact less than, then return it and the merge of the remainder. And otherwise, return the other element and the merge of the remainder. The only thing here, of course, is we're now doing more work than we need to because we're deconstructing that Y array only to immediately reconstruct it. We're never actually looking inside it in this variant. So we could just convert that back to the ordinary Y and save ourselves a little bit of effort as well. And now we have a pure functional multiple dispatch merge sort, which would look virtually identical in Raku or even in Haskell. Except now we can do it in Perl. So that's pretty much everything that I ever wanted from a Perl subroutine or method dispatch mechanism. But now there's a problem. And the problem is now I'm declaring 3 different versions of merge sort and 4 different versions of merge. And how the heck, when I call merge sort, does the multi know which of its variants to call? It was really easy when I was just deciding on different numbers of parameters. Because all I had to do was find the variant that had the same number of actual parameters as there were arguments. But it's not as easy when I've got different numbers of parameters and they have different type constraints on them, or different value constraints, or some of them required and some of them optional, or they have different destructuring behaviors. This actually is quite an ancient puzzle. And it boils down to, when there's only one choice, if you're passing in 2 arrays and only one of your variants takes 2 arrays, then you're golden. You can just go and do that immediately. But if you've got 8 variants, half of which actually will take 2 array references, how do you choose? And it's not even just array references. If you have 4 variants that all will take 2 integers, which variant do you select? And generally the goal here is to choose what we would think of as the best variant, or to be more precise, the most relevant to the argument list. And usually that boils down to which one is most specifically matching the nature of the arguments that you pass in. And this is actually quite a complicated problem because there are all kinds of different requirements for such a selection algorithm. You want it to deal with every possible case. You want it to be unambiguous in terms of it will always choose something that you can predict. You want it to be unsurprising. So when you look at a series of variants, you can pretty much guess which one is going to be called for any particular set of arguments. You also want the opposite. You want it to be predictable. You want to be able to easily write multiple variants and have them called at the time you expected. When you have multiple variants and you're ordering them by which one should be tried first, you want that process to also be stable. So if I later add another variant, that shouldn't mess around with the order of the ones that were already there. And above all, you want this process to be quick. You want most of it to be achieved at compile time so that runtime dispatch is as quick as possible. And if possible, you want it to be easy to understand as well. And as usual, you get to choose about any 3 of those in most of the algorithms that are available for this. This has been a long subject of research. If we go all the way back to August 1982, the first paper that seriously addressed it in a real language was the paper that introduced the Common Lisp object system. But since then, over the following 40 years, there have been lots of papers on lots of languages and lots of multiple dispatch module, including by some very disreputable characters. So over the last quarter of a century that I've been thinking about this for Perl, I have put a great deal of effort into finding an algorithm that meets all those criteria. Ideally, I wanted it to be as easy as ABC. In practice, what I achieved was something that was as easy as ABC, DEF, GHI, which I'm uncomfortably aware is bordering on AI. The algorithm works like this. A stands for arity. So if you're passing 3 arguments in, you can ignore and dispense with any version that doesn't accept 3 arguments. That's an obvious starting point. B stands for beforehandedness. So if you've got a multi-method or a multi-sub that is specifically marked as try this first, well, you just promote that and try that first. The C stands for checking the constraints on each version of the multi-method or multi-sub. And here the rule is very simple. If a particular signature has more constraints upon the parameters, then that is inherently more specific about its requirements, and therefore you should try that first. And those constraints don't have to be type constraints, they can be value constraints, aware constraints, and as you add constraints, that simply makes it more likely that the algorithm will choose that particular variant to try first. Now, of course, that worked great until you reach the point of saturation, where you've constrained every parameter. And then how do we work out which one to try first? Well, fortunately, in many situations, the constraints have an inherent order of their own. And here, for example, we can think of an int as a special kind of num and a num as a special kind of string. So we should naturally try the int one first before the num, before the string. And that works also very well in object-oriented constraints on arguments. If we're passing in an object, then we should try the constraint of the most derived type first. And that works great as long as all of the constraints agree on that ordering. But of course, that's not always going to happen. It might well be that the actual constraints were like this, where some of them say this one, this one, this one, and some of them go the opposite direction, and some of them go inside out. And that's why it can't just be simple as A, B, C, because you can get constraint situations where there's no obvious ordering. At which point we move on to the D criterion, which stands for destructuring. Any kind of signature where you're destructuring an argument to break it out and say it has to have a particular structure, that's inherently more specific than not saying anything about its internal structure. So we simply promote those variants that have more destructuring in them. If they all have the same amount of destructuring, which often will be none, then we can look at how many required arguments do they have? Because having a required argument is implicitly more specific than having an optional argument that'll match the same thing. So we promote those versions that have required arguments over those versions that only have optional arguments. We can do the same thing looking at the optional arguments. If we haven't got a unique ordering yet, we can just say, well, which of these have more optional arguments? They obviously have the same number of required arguments. But of course, having optional arguments is less specific. Facultative just means optional, but I had to have a word that started with F. So if they've got more facultative arguments, then they are less specific, so we should demote those variants instead. And the same for any kind of slurpy argument. Slurpy arguments are effectively less specific than saying I must have exactly this number of arguments. So once again, we demote the greedy versions. If that's still not enough to tell us the unique ordering of these things, then we can fall back, at least for methods, on heredity. Now, when you have a regular method and you call it on an object, you always start at the most derived available class for that method. And we should do the same thing with multi-methods. So we can look at the class in which these various multis were defined, and we can organize them so that the most derived one is matched first. And if all of those criteria fail to give us a unique ordering, then we just fall back on inception. What that means, of course, is that we simply throw all of the contestants into a non-Euclidean multidimensional dream space and we just let them fight it out. No, what it really means is we order them in the order of their inception, in the order in which they were declared. And when you put all of that together, you get an algorithm which can be completely determined at compile time, where you simply look at all your variants, check their arities and order them by arity, check whether any of them are beforehanded, they are not, count the number of constraints that each of them have, count the number of destructures, how many essential arguments do they have? Well, 2 each. Do they have any optional? No. Any greedy arguments? Yes, within the destructures they do, so that weighs against the ordering of those ones. There's no heredity here. They're already in their inception order. And now all you do is you float the good stuff, the ABCs, to the top and the bad stuff to the bottom. And that gives you a unique ordering for those. And if you think about it a little bit more, you'll see that that ordering is completely comprehensive. It'll cover every possible signature unambiguously. And it actually provides relatively unsurprising and predictable patterns of behavior. Basically, the more constraints you have on it, the fewer optional arguments you have on it, the more likely it is to be chosen. It's also stable and very quick because it's being done predominantly at compile time. So it matches 6 of the 7 criteria. Whether it's easy, that one I'm not so sure about. In the 4 years that I've been developing this software, it seems to do what I mean most of the time, and I hope that if you start to use it, it will do what you mean at least some of the time. Now, I'm pretty sure I know what you're thinking at this point. Something that complicated, something that powerful, something, frankly, that Damianical, there is no way we're ever getting that in core. Even though it's core in Raku, even though it's core in Haskell, even though it's core in a dozen other languages as well. But of course, you don't have to wait for it to be put into Perl 7 or more likely Perl 17. All you have to do is load the module. And all of the examples that I've shown you will just work. So how does it work? Well, there are monsters ahead here. The module simply uses the PPR module to parse that new syntax. So I wrote a big regular expression, about 136 lines long, that implements all of the variants that I've shown you of that syntax in correctly parsed Perl. And then I simply installed the PPR grammar, which turned it into a 2,136 line regex. But now it will parse any Perl file and correctly identify the new multi-components. So the code itself is relatively simple. We simply create a new keyword called multi. That keyword gets passed the source code, and it simply looks for a match against this new multi-parser Perl syntax. If it finds it, then the syntax will have captured in named captures all the relevant information we need to translate that multi-method or multi-sub back into regular Perl. So we just call a subroutine that does that for us. That generates the standard replacement code, which we just insert back in place of the keyword. And that means that any time that I create a multi like this, which has a couple of parameters, which have some constraints upon them, that module will translate that into this code instead. And that code is all in a begin block. So it's all happening at compile time. And mostly what it's doing is installing a subroutine that manages the dispatch of this particular calls to report. So anytime report is called, if we haven't already installed something that works out which variant to call, we install this subroutine. And that subroutine just goes through and looks up a table that's kept in the module of all of the variants that have the name report that belong in this package. And that gives you back a list of records of the different variants, and you then simply go through those variants, shifting each one off in turn. And the first thing you do is check whether this variant happens to take that many arguments. And if it doesn't, then you go straight on to the next variant. But if it does, then you do a more sophisticated test. You test whether the signature of this particular variant satisfies the arguments that have been passed. So you call this subroutine that works out whether this variant is suitable for handling this particular call. And that subroutine returns one of two things. If this variant is not suitable, it returns undef. If it is suitable, it returns a handler, which is effectively just the body of that variant. So this is what you do if, in fact, this thing works. So if you get back a proper handler rather than undef, then you simply execute that handler by replacing the current dispatcher on the stack with a call to that variant. So it's as if you originally called that variant. Now, of course, if you go through the list of variants and none of them will accept this argument list, then you simply throw an exception saying, hey, this is a bad call, you can't do that. And then for each variant that you declare, you have to add that to the table of variants for this particular multi-sub in this particular package. So in other words, you just assign to that table all of the existing variants plus a record of the new variant. And that record records what package it belongs to, records its minimum and maximum number of arguments. It records its A, B, C, D, E, F, G, H, I characteristics. It also records its signature, so you can compare signatures to see if there's an inherent ordering between variants. And it includes that subroutine that tests whether or not this particular variant will match a certain set of arguments. And the way that that works is it simply goes through and applies each of the constraints that you mentioned in the declaration of the variant to the argument list. So for example, the second argument for this variant has to be a hash because we're going to assign it to a hash alias. So it's not, then we immediately return undef, indicating not this variant, thank you very much. Otherwise, we unpack the parameter list into the same signature as the variant specified, and then we do the individual tests on the variant arguments. So this example required that the first argument had to be defined. So if it's not defined, again, we return undef, saying this particular variant won't handle this. But if we get through that gauntlet of all of those tests, then we can just return a subroutine consisting of the actual body of the variant, the code that the variant is supposed to execute. And that body is simply put into an anonymous subroutine, which closes over the parameter list that we've already unpacked. So we don't have to re-unpack it. We don't have to check any of the arguments within the body because it's already been done by the filtering mechanism that determines which version of the method we are going, or subroutine we are going to call. And so we simply take that subroutine and return that as our handler, and then we simply execute that. Now, having added this new record to the list of variants, we have to make sure that the list of variants is in its appropriate, most specific to least specific order. And we do that by sorting it. And that sort should really be called sort topologically on the signature, and if that fails to give you an answer, sort on the precedence string. So in other words, we compare the constraints of the signature to find the most specific and order them by that. And if that doesn't give us a unique ordering, then we simply do a string comparison of these precedents and we promote those which have the highest precedence. And that gives us our unique set of variants to be executed. Now, if the multi also happens to use that next variant behavior, then we need something a little bit more sophisticated to support that. Because here in the dispatch loop, when we find a variant, we're actually replacing the entire dispatching subroutine with a call to that variant. So it's very hard to say, no, go back and keep dispatching. To do that, we have to factor the dispatch loop out into a subroutine. And then within that subroutine, we're going to capture the set of variants that we're iterating through and carry that along with us. But what we're also going to do is we're going to pass some extra information into the ultimate handler that gets chosen. And we're going to do that by just adding an extra pretend parameter to the end of the argument list. And that's simply going to be a reference to the subroutine that we are inside. And we'll see how that works in just a minute. But now, of course, we don't have a dispatch loop anymore. We have a subroutine reference there that's not actually going to be executed. So we have to make sure that it's executed at that point. So we have to put it in a magic goto as well. And when you magically go to an anonymous subroutine, that's just the same as executing that block of code in this position. Except that because it's now a subroutine, we can pass in a reference to it to the handler that we eventually dispatch to. And then in that handler, we can simply unpack that reference, popping it off the argument list before we do any of the testing. And we can alias that dispatch loop as next variant. So when you call next variant, it just executes the subroutine that we passed in, which is the subroutine that has the dispatch loop, which is the closure over all the variants that we were already dispatching. So the next shift will shift the next one off and we resume our dispatch loop. Told you it was monstrous. A good friend of mine recently asked me what is my favorite ever use of closures, and that piece of code is it. It's elegant, it's efficient, it's clean, it just works brilliantly. It's the favorite bit of code that I think I've ever written. So this module has plenty of other clever tricks that you can discover. Plenty of other features and abilities that will make your coding better. It's called multi-dispatch. It's on the CPAN now. Will it ever be in core? Well, I certainly submit these ideas for consideration by the steering committee, and I will use all of my limited Jedi mind powers to try and encourage them to look at it. But it's there as a module for you to use right now. So that was my attempt at applying past technologies to improve Perl's future. Now I want to switch it around in the last third of this talk and apply present technologies to Perl's future by reinventing its past. Because I haven't even talked yet about the very best feature of multiple dispatch. And to understand that, we have to go all the way back to July 2000 when I released the switch module. Now, of course, nowadays, here in the future, the switch module is also extremely last millennium. Not the least of which because in 2007, it was replaced by a built-in feature that gave us the ability to replace ternaries with this nice given-when syntax, where you could say, I'm interested in this value. When it matches any of these, do something else. And of course, that's available today. In the most recent version of Perl, you can use switch and its smart matching characteristics. But it's not going to be available next year. In Perl 542, that feature is going away. After a quarter of a century of being available in some form and a sixth of a century of being in the core, switch and smart matching are now officially a dead parrot. Now, I'd probably be more concerned about all of the code that's going to break out there when 542 comes out if it weren't for the fact that I just released a module that's capable of giving you the same behavior in a cleaner and neater format with multiple dispatch. Because multiple dispatch, at least with the multi-dispatch module, can do everything that a given and when sequence can do, just breaking it up into multiple different versions of the same subroutine or method. And so I think to myself, well, you know what? if multiple dispatch has all of the capacity of given and when and smart matching, so maybe smart matching and switches aren't actually going to have to die when they're removed from the core. Because I have keyword declarations and I have now multiple dispatch, so how hard could it be to resurrect switches in a module after they're gone from the core? And of course, turns out, not very hard at all. I actually timed it. It took me 37 minutes. All I did was create a series of keywords and a series of multiply dispatched implementation of the smart match algorithm. And those keywords simply take your code with the now illegal given, when, continue, break, etc., identify the keyword and replace it with still valid Perl. The givens become unconditional ifs, which uniquely mark each given block with a unique identifier, which they store in the lexical hints hash, so it's available at compile time throughout that scope, but nowhere else. And then they do what a given does. They localize the underscore, they copy across the expression that was in the given block, they execute the given block, and then I add a special empty label at the end of the block as a target to jump out from if you ever do a break. And then the when does pretty much exactly the same thing. It converts to an if statement that smart matches $_ against whatever the when value was. It also creates its own unique label for the when block this time in a lexically scoped entry in the hints hash, executes the when block and puts in the automatic break at the end of any when. And then once again, we add a target for jumping out of a when block, but not jumping out of the given. The default works exactly the same way, except it's an unconditional if because there's no condition to test. The break command simply gets converted into a jump, into a goto, and it jumps to whatever the current value of the end of this given block is, which of course is in that lexical hints hash. So we effectively copy that down at compile time, and now we have a hard-coded jump out of the given block. And likewise, the continue does the same thing, a goto to the end of the when. And we simply, again, at compile time, copy that out of the lexical hints hash, and now we have a hard-coded jump out of the when and on to the next alternative. So that's the syntactic element of it. The semantic element of it, of course, is we have to re-implement smart match, which is also disappearing in 542. And to do that, I literally just went to the documentation, grabbed that table of values, and converted it into multis. And those 43 lines of code that I wrote implemented about 80% of the complete built-in functionality of given, when, and smart match. So according to the 80-20 principle, the rest of it should have taken maybe about 2.5 hours and a couple of hundred lines of code. And of course, the 80-20 principle is a load of rubbish. It's the 80-80 principle, so it actually took about 10 times as long as that. But the result is the switch module is back, baby. And the module is going to be called switch back. It has no nasty source code filters. It has no edge cases where it won't understand the Perl syntax properly. And it's not going to go away in 2025 when the built-in feature ceases to be built in. It's on CPAN now. So for those of you who need that backwards compatibility, it's now available. And you'd think I'd be fairly happy with that. But you know what? I really wasn't. Because in my experience, the whole point of being able to time travel is so that you can revisit the past in order to change something that changes the present. And the reason we want to change the present is because we have to improve or save the future, because we really don't want Biff Tannen running everything. The point here is switch and smart match are going away next year for very good reasons. And those very good reasons are simply this enormous table, these 23 rules that no sane person can actually remember. Here they are. They'll be on the test later. Memorize them. And it's even worse if you're using given and when, because in addition to using the 23 rules of smart matching, given and when have an extra 23 special case rules for when. And those extra rules are even weirder because 2/3 of them don't even use the left-hand argument in the smart match. They simply say, if there's a Boolean expression, just take the value of that Boolean expression as the result of the smart match without even considering the left-hand argument. And the last 5 do exactly the opposite. Not only do they require the left-hand argument, but they kind of sprinkle it like fairy dust into the middle of the expression in a way that nothing else in Perl does. So if someone asks you why switch and smart match had to go, there are 46 incredibly good reasons for that. Now, I think the basic idea of the switch statement is a good one. It's a clean syntax that makes some things easier to maintain. And I think the idea of matching on the basis of what you're given is also a good idea. But I don't think that having 46 impossible rules that you have to remember in order to do that is a good idea at all. So I think my original mistake was in the naming of this. I shouldn't have called it smart matching. If I just called it clever matching instead, then Kernighan could have rushed into the room and told me, if you design a feature cleverly as possible, then by definition, you and no one else is going to be able to use it. So, of course, that was a case where my useful superpower of micro precognition didn't help at all. But like most people, I actually also have the opposite superpower, that of macro post-cognition, of slow hindsight, of being able to recognize about 25 years later just how stupid you were at the time. And that really is a superpower, because if you can envisage what you could have done better in the past, then you can probably think of ways to make the future brighter. So in this case, I thought to myself, well, what if smart matching hadn't required 46 rules to work? What if it had required maybe just 6 rules? Maybe it wouldn't have to die. What if it had these 6 rules? What if I took the 46 rules and just picked out the sensible bits of it, the bits people can remember, and maybe added one extra thing? And that one extra thing deals with a lot of the other cases, and it's this. Perl now has canonical true and false values, values that you can recognize as being intended to be Boolean true and Boolean false, not just some arbitrary number or some arbitrary string or an undef. So the first new rule would be that a smart match against true is always true, and a smart match against false is always false, no matter what the other argument is. And yep, this is something I stole straight out of Raku, but it works so well because it means that any time your right-hand argument is a Boolean expression that returns a canonical true or false value, then smart match just uses that expression, like those 18 weird rules of when, except now it's just one rule. If it's a Boolean, you just take the Boolean value. And that means that all of these given and whens would continue to work, only now with 95% fewer rules to remember about why they work. Now, of course, that would also mean that people would do silly things like this and say, okay, I'm going to put a Boolean expression in my given, and if it's true, I'll do this, and if it's false, I'll do that. And of course, that doesn't work because true and false don't care what's in the given. They just always return true or always return false. But of course, in that case, because it's a fixed and obvious value, you could just have the compiler point out, you know what, that's not going to do what you think it's going to do. You need to go home and rethink your life. So that one rule replaces those 18 special cases. The next 5 entries in the table are in fact just one rule. And that one rule is if you have 2 refs of the same type, if you have 2 references of the same type, then those 2 things must match exactly. If they're 2 arrays, the arrays must have the same number and type of elements and the same values. If it's a hash, it has to have the same keys, and those keys have to have the same values. If it's 2 code references, they have to refer to the same subroutine. If it's 2 regexes, they have to have the same pattern inside them. If it's 2 undefs, they have to both be undefs. And then the last 4 rules are simply variants on the well-known rules. What do you do if you match a code reference? Well, you just pass the argument to the code reference and see what happens. What happens when you match a regex? You just pattern match against that regex. What happens if you match something that's a number? Then you actually just do equals equals. Anything else you do EQ. The only thing here is that 2 of those, I'm changing the behavior very slightly. Because in the current implementation of smart matching, if I, for example, match a reference to an array against a subroutine reference, then rather than passing that array reference into the subroutine and getting back a result, it actually does this thing. It passes each of the values of the array separately into multiple calls to the subroutine, and it requires that all of those calls return true for the smart match to occur. And that's just too complicated. No one remembers that. So instead, I'm just going to suggest, hey, we just pass it in. In all cases, if you've got a subroutine reference on the right, you just pass the left argument in, even if it's an array or a hash reference. And there's something similar going on in the current version of smart matching if you do a regex match against an array reference. In that case, it simply takes all of the elements of the array and matches them against the regex, and if any of them match, it does. Now, why that's any and the other one was all, nobody seems to know. It's just one of those magical things you have to remember, which is too damn hard. So I'm just going to change that. I'm just going to say, if you try and match an array reference against a regex, that's just automatically going to be false from now on, because arrays are only going to match against other arrays and hashes are only going to match against other hashes. You're not going to have any of these magic try to match all of them or try and match any of them, at least not yet. So that's the new table. And of course, it translates directly into a single page of smart match multis, which implement all of those entries of the table. The only parts of the table it doesn't implement correctly are the ones that's doing all of that distributed ands or distributed ors, the anys and the alls and all of that magic, the magical conjunctives and junctives. So set membership, list membership, matching n tests all at once, matching any of n tests one at a time, but no one knows what it's doing. So how can we support those in a way that don't require me to learn another 40 rules? The answer is we can do that by going back to June 2000, when at YAPC 2000, I released the quantum superpositions module. And with the quantum superpositions module, you could say, don't match this value against a list of things and have to do a lookup to find if any of them match. Use the quantum superposition and just say, match against any of these things explicitly. And what that should do then is distribute the test across each match and say, if any of them match, we're okay. And then, of course, all would do the same thing, but require that all of them match. And none would do the same thing, but require that none of them match. Unfortunately, even though that would work perfectly in Raku, which has exactly this syntax available, it doesn't work under quantum superpositions, because quantum superpositions can't intercept function calls and distribute them across the values of a junction. Instead, what it does is any, all, and none convert your list into a disjunction or a conjunction or an injunction object. And they pass that object in, and then the subroutine has to work that out. And of course it doesn't, because smart matching against an object is immediately a violation of encapsulation. So how could we add these kinds of any, all, or none to multis? Well, we do that the same way that we add anything else to multis. We just define a few more variants. So in addition to these 2-argument smart matches, we could define a couple of 3-argument smart matches, where the extra argument has to be any, all, or none in front of either the left or the right operand. And all you do then is you say, well, if I get that explicit extra argument saying I want any, all, or none, then make the test any, all, or none of the appropriate list matches the other argument. And then, of course, you do the same, providing the 9 variations of having both of those extra arguments on there. So if you have any of this matches any of that, then you would nest those 2 distributed tests and get the final result. At which point you can explicitly say, I want to smart match this value against anything in this list. So any of the keys of this hash, or I want to match all of these requirements, or none of these. I don't want it to be undef and I don't want it to be a prime number. Or I could say none of the values can match undef, or none of the keys of this hash can be an empty string. Or all of these names have to match a particular name format, or any of these names can be one of the suspects. Or all of these keys can't be empty string or have a digit in them. And of course, to make that work with given and when, then we need a couple of extra variants of those keywords, where you're allowed to put any, all, or none, followed by a comma, in front of the expression that you're passing to the given or the when. And if you put an any, all, or none in front of the given, then it simply records in the lexical hints hash that this given block is an any given block, or an all given block, or a none given block. And then in any call to smart match within that context, you simply insert that any, all, or none as an argument in front of the leftmost argument. And then you do the same thing with when. If the when has an any, all, or none as part of the expression, then you simply interpolate that in front of the right-hand argument. And now, in addition to writing smart matches with explicit conjunctions and disjunctions, you can write givens and say, given this value, when all of these match. And now it's not secret magic. Now it's not 46 rules that you have to remember. Now it just says what it wants and does what you mean. And ultimately, this demonstrates the very best thing about multis. Not only do they do half the thinking for you in working out which version to call for you, they let you do the half of the thinking that you have to do incrementally. I hadn't initially thought of having any, all, and none in my given and when, but it was perfectly possible to add it to smart match afterwards when that hindsight showed me what I needed. And it lets someone else do that as well, because any kind of multiply dispatched subroutine or method is inherently extensible at any later time, even if you're not in charge of the original variance. You don't have to change the original variance, you can just add something new. So for example, smart matching against objects always fails. And it fails in part because overloaded smart matching operator is soon going to be going away, so I couldn't implement it that way. But mostly it fails because it doesn't matter that it fails. Because if you have a given when with various kinds of tests being done, and one of those tests happens to be, say, an ID validator object, then obviously that's going to fail because you can't smart match against an object. Except that because smart matching is multiply dispatched, you can decide when you create this object to tell smart matching how to do it. You can add a new variant which takes an ID and an ID validator object and simply calls the appropriate method of that object on the ID. And now you can put that in there because now there's a smart match variant that will handle it, and it just works. And that, my friends, is the best thing about multis. As a designer of language, as a designer of a module, I don't have to think of everything in advance. And as a user of that language and a user of that module, I don't have to hope that the designer thought of everything at once. Because any interface that is based on multiple dispatch will inherently be adaptable to new needs without breaking the old code. And that's why I think multiple dispatch is the bee's knees. So switches back twice and going into the future. What to call this new and improved version of switch? Well, the old version, the backwards compatibility version, was called switch back. So initially I thought maybe just switch forth or switch to or switch up or switch on or switch over. And then I thought, no, it needs a catchier name than that. And I thought maybe I should call it the given adder. Or perhaps when given lemons. And I was so tempted by that one. It was terrible. But what I realized is what's really going on here is that I've redesigned smart matching with the right number of rules, just 6 of them. And with a principle that only the right argument determines the behavior of any smart match. So in other words, it's like the original switch, but done right this time. At that point, the name was obvious. It's called switch right. It's on the CPAN now. Will it ever be in core? Well, I highly doubt that. But you never know, the lure of the dark side has turned more people than just the steering committee. So let's just finish off by updating my stats. In the last quarter century, I've now written just over 3.8 million lines of code, representing around 2 to the 8th CPAN releases of 86 modules, given 306 presentations, totaling closer to 1,020 hours. I apologize for the length. But that doesn't tell the real story. Throughout the last 25 years, Perl has been my mad science laboratory. It's been my playground. It's been my community. And I'm proud of what I've been able to contribute to this community. And I'm thankful for the opportunity that I've had to do that, and for the adventure that it's been doing it. And above all, I am profoundly grateful to every one of you for your friendship, for your encouragement, and for the very practical kinds of support that you've given me that made that possible. So now, after 25 years, the only thing I have left to say is the thing that I always say. From the bottom of my heart, thank you.
And so I'm back. From outer space. You just walked in and found me here with that mad look upon my face. You should have purged this hollow vid. You should have guessed how it would be. If you had known for just 1 second, I'd corrupt TPRC. So now I'll go, lay waste your dream. Turn Perl to Silos was my 25-year scheme. Weren't you with those who tried to hurl me down to die? Did you think I'd tumble to that reactor core and fry? Oh no, not I. I will survive. As long as I embrace the dark side, Switch will stay alive. And the goal for which I live, to bring back Smart Match to the Sith, I shall contrive that it revives. Hey, hey.